Hey Christina, so in answer to your question, in order to find the oxidation state of the sulfur, first of all we need to realise that this is a hydrated salt, so we've got 5 water of crystallisations, but the oxidation states in the water, they're just going to cancel out. Hydrogen is +1 and there's 2 of them, oxygen's -2, so they're just going to cancel out. We can ignore that and just focus on our salt. Now, one of the most important rules of oxidation states is to realise that the charge of the thing will be equal to the total of the oxidation states. Now we have no charge here, look there's no number there, I'm not pointing at anything, so all these oxidation states need to add up to 0. We then need to go through all of those rules we know about oxidation states. So sodium, as it's a group 1 metal, will have an oxidation state of +1, and there's 2 of them. Oxygen is almost always -2. So I've got -6, add the 2, so far I've got -4, and I need it to equal 0. So that means each sulfur must be +2. So the answer is +2. That's just going through those rules. You know, oxygen's -2, hydrogen's +1, group 1's +1, group 2's +2. Fluorine's -1, an uncombined element is 0, and an ion is its charge. They're the rules to remember. Your other question was about oxyanions, so things which end in 8 generally. And you asked what these Roman numerals mean. So if it's next to just a metal, the Roman numeral tells you the positive oxidation state of the metal. And it's always positive. So iron 3 tells me I have iron with an oxidation state of +3. Nitrate, well, an oxyanion is oxygens bonded to another element and they'll have a negative charge. So nitrate, obviously the other element is a nitrogen and there's going to be a certain number of oxygens. Now, because the +5 here, there's V, that's the Roman numeral for 5, that just tells you the positive oxidation state of the nitrogen. So that tells you the nitrogen is going to be +5. Now, you've not written this in the question, but I'm guessing it said the overall charge of the nitrate was -1. It usually is. That might not always be the case, but I'm guessing it was for this one. If that is the case, we know our total here needs to be -1. We know that the nitrogen is +5. So how do we get from +5 to -1? Well, each oxygen's -2. So we're going to need 3 oxygens. So the formula will be FeNO3. And then as iron is 3, and that's each of these is -1, you'll need 3 of them. Okay, so this Roman numeral tells you the positive oxidation state of the non-oxygen in your oxyanion. And an oxyanion is an element bonded to oxygens that has a negative charge.